we'll be starting with current electricity. And to understand what current electricity is, we have to give its definition, the formula, and the units. But first thing is first, when we've already introduced what current electricity is. So when somebody talks about current electricity, the first thing that should come to mind is charge in motion, charges that are moving. But in definition, current electricity is defined as the rate of flow of electric charge along a conductor. The rate of flow of electric charge along a conductor. How fast charges are moving on an electric conductor. Mathematically, the formula for current is given as quantity of charge over time. Current is given as quantity of charge over time, and it can be written, represented with this formula. I, which stands for current, quantity of charge, Q over time, which is represented by T. Now, the SI unit for current is Ampere, which is represented by A. And another unit for current is coulomb per second, which is derived that the unit for charge is coulomb and unit for time is seconds. So together you have coulomb per second. But the SI unit for current is Ampere, which is represented by A. Now, you are just starting your journey learning about current. There are different magnitudes of current, different sizes of current. From the current, the power plants are supplying through the power holding company to our homes, which are a larger quantity of current. But because you're just starting, we will be talking about very little magnitude of current. The first one is milliampere. It's a very small current. It's represented as 1 mA. It's represented as 10 raised over minus 3 ampere. 1 milliampere is equal to 10 raised over what? Minus 3 ampere. Another one is 1 microampere, which is 10 raised over minus 6 ampere. Another one is 1 nanoampere, which is 10 raised over minus 9 ampere. And the last one we have here is 1 picoampere, which is 10 raised over minus 12 ampere. These are very small current because you are a starter in beginner currents. You will not be asked to play with very large type of current. We will be talking about very small currents. Now that you have the formula for currents, you can quickly make Q the subject of formula as a way of playing mathematically. You are asked to make Q the subject of formula to be Q is equal to IT. If you are asked to make T the subject of formula, it will be T is equal to Q over I. So whichever way you can be asked to find the value for Q, the value for T, or the value for current. Let's quickly play with an example. It says a current of 35 ampere through a car headlight. How many coulombs of charge flow through it in 1 hour? So let's pick out our variable. I told you that current is flowing through an headlight of a car. The magnitude of current value is represented by I. Current is equals to I is equals to 45 ampere. And we are asked to find what? Say how many coulombs of charge. That is, you are looking for what? Q. So represented with the question mark. That flow through it in what? 1 hour. So what time is 1 hour. Now, if you notice, please be careful. Things start to align. The unit of current is ampere, which is the SI unit. But the unit that is given for time here is hour. Though it's a unit for time, it is not the SI unit for time. So what you have to do before you calculate is to align everything in SI units. You have to put this hour in seconds. So convert 1 hour to seconds. Converting 1 hour to seconds, you times 1 times 60, which is converting the hours to minutes, times it with another 16 again, 60 again, it becomes seconds. So 1 times 60 times 60, which is 3,600 seconds. With this, you are good to go. Let's go. Now the formula is I is equals to Q over T. Current is equals to charge over time. And you are looking for charge here. So make Q the subject of the formula. So it becomes Q is equals to IT. Now Q, our I here is 4.5. Okay, so it's 4.5. 4.5 times our time in seconds is 3,600. Now if you times that, we are going to get 16,200, and the unit for charge is coulombs. So the calculations are not hard. I either calculate for current charge or time. So to test what you are doing at, I'll just say test yourself what is current. Say it with your mouth. You can't say it with your mouth, it means that you don't understand it. So try and say what current is. Define current. Okay, there's this something here. For you to test your knowledge from the calculation, you work it out. They determine the current. So you are looking for what? Good. You are looking for current in a conductor with 20,000 ampere in 2 hours. So your time is 2 hours, your current is 20,000 ampere, and you are looking for current. So quickly solve it. you are done, the answer for current should be 2.78 ampere. If you do it very right, 2.78 ampere. Now we have just learned the definition of current, or you can say current electricity. You know the formula for current, the SI for current, and you can do calculation with the formula for current. Now, when currents are flowing through a conductor, they are devices specially designed to measure these currents. They are devices. Well, the first device is ammeter. The first device is ammeter. Here we need is a device called an ammeter. This is an ammeter. It is designed to measure current. There are still other variants of ammeter. You see, a mini ammeter, micro ammeter. But when you have very, very small current, another device that is designed to measure it is a galvanometer. A galvanometer. So, a ammeter, if you ask what is the device for measuring current, the first answer could be a ammeter. But a galvanometer is designed to measure small, very small currents. To measure very small currents. Now, there are some things that are associated with an ammeter. You can say an ammeter is sensitive, or an ammeter is accurate. When you say an ammeter is sensitive, an ammeter is said to be sensitive if it can detect very small currents. An ammeter is said to be sensitive if it can measure or detect very small currents. An ammeter is said to be accurate if it can measure close to the true value. So it doesn't matter the value, if you can measure close to it, we say that ammeter is accurate. For example, if a current flowing through a conductor was actually 4.33 ampere, this is the actual current flowing through the conductor. But when you use an ammeter to measure it, you're not getting 4.0 ampere rather. Though the approximation you say is correct, but you still see that a value like 4.2 ampere, 4.30, 4.322 ampere. All these values are close to 4.33. But you agree with me that 4.25 ampere. You agree with me that this last value is very close to this value. That is what we mean by ammeter being sensitive. An ammeter is accurate. An ammeter is said to be accurate if it can measure close to the true value. Now we are talking about current flowing through a flowing. The rate in which it flows. Where does current flow? Does current just flow on its own for free? Where does current flow? Now the truth is that there are some material that allow easy flow of current, and there are some material that doesn't allow easy flow of current. Now those material that allow easy flow of current is what we call a conductor. Conductor are material that allow easy flow of current. While material that does not allow easy flow of current, we call them insulators. Or rather, poor conductor. They do not allow easy flow of current. They do not allow easy flow of current. An example of good conductor is almost all metals. Almost all metals are good conductor. Name it aluminum, iron, silver, gold, copper. They are all good conductor of electricity. Please be careful. The word conductor is also meant for heat. So you have thermal conductor or heat conductor. You also have electric conductor. That is material that allow the flow of charges easily. Now, apart from most all metals that are examples of good conductor of electricity, you also have inorganic acid, you also have damp air. Now, we want to talk about the term called resistance. In every material, whether a conductor or an insulator, they have one property called resistance. What is resistance? Resistance is just the opposition of flow of current. Resistance is the opposition of flow of current. Charges are moving in a specific direction, but there is an opposition to this flow of current in this specific direction. That opposition to the flow of current is what we call resistance. All material have different degrees of resistance. Now, the unit in which we use for calculating resistance is ohms. Noted by this letter ohms, spelled H-O-M-S. That is the unit for resistance. The unit, now that we learned what the conductor and insulator is, now if you set up a conductor and you allow current to flow, we have learned that these conductors have various resistance. But if you allow current to flow through it, it's really a good conductor. Now, this setting up of current is what we call what? It's called an electric circuit. So, a simple electric circuit, what does it consist of? We are going to learn what a simple electric circuit consists of. And apart from resistance, there's another key major factor that affects the flow or determine the rate of flow of charges in that conductor, which will lead us to what we call potential difference. How much work flow of charge between two terminals in an electric circuit. That will learn other names for potential difference. Now, in this electric circuit, it does not just consist of a conductor, there are other components we are going to see. Now, when you have other components in an electric circuit, the way you connect them together now leads us to the discussion of parallel and series connection. We will discuss parallel and series connection.